gathering data for hazard analysis. The next section is the hazard analysis, which is critical because it drives decision-making for the preventive controls that must be included in the food safety plan. We're going to spend a little bit more time talking about hazard analysis here before going into the other sections of the food safety plan because it is so critical. For each step in the process flow, from receiving ingredients to the final product leaving the facility, a determination of potential hazards needs to be done. Once hazards have been identified, an evaluation needs to take place to determine if that hazard requires a control. The severity and likelihood of the hazard are parameters that are evaluated. If the hazard is both severe and likely, then assessment of whether prerequisite programs like GMPs adequately control that hazard is conducted. If the hazard is not addressed by prerequisite programs, then the hazard may require a preventive control in the process. It can be a challenge to determine what types of hazards are likely or reasonably foreseeable to occur in different products. An important first step is gathering data. This can include information on previous recalls or outbreaks in products similar to yours, information from scientific reports or other guidance documents. It is also important to consider not only products exactly like yours, for which data may not exist, but also other products in related categories or even raw materials that you are using. Here are a few examples, just to illustrate the approach that can be used and provide some useful information. Both the FDA and USDA post recall information on their websites. You can search by category there, and it's a good place to start. Next, we will touch on some examples of products and associated hazards. The first example I want to walk through is ice cream. Recalls and related products, ice cream. For ice cream, we do have a large-scale outbreak that occurred in 2015 due to Listeria monocytogenes. This outbreak was linked to a large-scale producer of ice cream with 2 production facilities. If there's an outbreak in a product like yours, best practice is to dig in and try to find out what went wrong that led to the outbreak. Oftentimes, you can find the FDA Form 483 or inspection report from outbreak investigations. In this particular case, the ice cream manufacturer had positive product and environmental swabs for Listeria monocytogenes. However, the corrective actions they undertook were not effective. It is important to see what goes wrong in these outbreaks so that mistakes are not repeated. In this case, an environmental pathogen, Listeria monocytogenes, was present in the freezer tunnel and in a drain outside the freezer tunnel. The facility was aware, tried to implement some corrective actions, but those were not effective in controlling the hazard, and as a result, people got sick, and their facility was shut down. Another resource that I point to here is a guidance document from the FDA. This resource lists potential biological, chemical, and physical hazards for different product categories and processes. For ice cream, the biological hazards identified are pathogenic E. coli, Salmonella, and Listeria monocytogenes. This guidance is very helpful for those with less experience conducting a hazard analysis. Here's another example. Oftentimes, refrigerated products can have less regulatory stringency than other shelf-stable products. However, temperature abuse can cause significant hazards. One very important consideration for a product that is heated during the process and then cooled for refrigerated storage, like soup, is cooling down in a rapid fashion to reduce the risk of microbial pathogen growth. Some types of bacterial pathogens, like Clostridium perfringens, the pathogen that caused this outbreak in minestrone soup, form what is called bacterial spores that are resistant to high cooking temperatures. In a product like soup that is heated to boiling temperatures, these spores will remain, and if the product cools slowly, those spores can germinate, and the bacteria will grow, producing a toxin. If we look at the FDA hazard guide for refrigerated soup, the first 3 biological hazards marked are spore-forming bacteria. Bacillus cereus, Clostridium botulinum, and Clostridium perfringens. Also flagged are Salmonella and Listeria monocytogenes. These are considered environmental pathogens and can often recontaminate products and expose to the environment after a kill step, like cooking. Here's another example. Another example of when cooling is very important is for products that contain rice or pasta. Bacillus cereus is a spore-forming bacteria that is very common on grains. It can cause issues in rice or pasta that is not cooled properly. This bacterium produces a heat-stable toxin that will remain even after reheating. I also want to point out in this hazard table that as a product becomes more complex, for example, the more ingredients or the more unique the processing, the hazards tend to increase. Here's an example of chemical hazard. Chocolate is an example here. You can see heavy metals, unapproved colors and additives, and natural toxins being flagged as chemical hazards. This product is high value and produced outside of the US. Different environmental and food safety standards, as well as potential economic adulteration, can be issues. Then finally, an example of a physical hazard. I want to show this to highlight the physical hazards that are identified for beverages like cola, sparkling beverages, etc. Glass was identified as a hazard if a product is packaged in glass. A food processor must have a glass management plan to reduce the risk of glass hazard to consumers.